graphing and solving quadratic inequalities, okay? When we are doing this, we're going to follow 3 steps, okay? The first step is to graph the parabola with the equation y equals ax squared plus bx plus c. Okay, graph the problem. Make the parabola dashed for inequalities with less than or greater than, solid for less than or equal to, or greater than or equal to.
Are you taking our homework that we did a couple days ago?
Um,
Oh yeah.
Yeah, I need to at the end of this one. Step 2 is test a point. Test a point inside the parabola to determine whether the point is a solution of the inequality. And then step 3 is to shade. You're going to shade the region. Let me see how to word it. Shade the region inside or outside. That has a solution point. So we're going to do 3 steps in graphing. Y is greater than x squared plus 3x minus 4. So the first one I want to graph is y is greater than x squared plus 3x minus 4.
The number 3 you said has a solution point, so there can be more than one answer, or is it just one? Like,
There's going to be multiple answers because you're shading a region. You just have to shade a region that includes one of the solutions.
Okay.
Okay, now, talk to me. How do I graph something that says x squared plus 3x minus 4?
Find the opposite of v over 2.
Yes, opposite of b over 2. Is it over 2a or is
I
it
think it's 2a. I think it's 2a.
Yeah, I think it's 2a. Opposite of b over 2a. Because it's the same as graphing a standard equation, yes? From, was it earlier in the chapter that we did that? Yeah, when we split it into 2 pieces, remember, 2 segments. So you're going to graph it by finding the opposite of b over 2a. So what's the opposite of b?
Negative 3.
So I'm going to do opposite of b over 2a, which equals negative 3 over 2 times 1. So you get negative 3 over 2, yeah?
Yes.
Okay. What is negative 3 over 2 then in this case? If I use the opposite of b over 2a, what am I finding?
You're finding
What do you have to find?
x.
X of what part of my parabola?
Your vertex.
My vertex, good. My vertex. So part of my vertex right now is negative 3 over 2. I plug this in to find the y of my vertex. So I'm going to say negative 3 over 2 squared plus 3 times negative 3 over 2 minus 4. What is negative 3 squared?
9.
What's 2 squared?
4.
So I have 9/4. And I'm going to have minus, right? Because what's 3 times negative 3?
Negative 9.
So I'm going to have minus 9 over 2 minus 4. Okay. 9 over 2. I need to change that to a 4, right? So that I can subtract. So I have 9/4 minus, I would multiply this by 2, 18/4, yeah?
Yes.
And if I change this to fourths, what do you get?
16 over 4.
Yep, 16 over 4, good. So what's 9 minus 18? Negative 9. And what's negative 9 and negative 16 together?
Positive.
No.
Well, I mean, with negative.
Negative 27? No, not
Negative
25.
25.
There we go. So you have negative 25 over 4, yeah? What is negative 25 over 4? You guys like decimals better than you like fractions. So how many times does 4 go into 25?
6 times.
And that gives you 24, right?
Yes.
With a remainder of 1.
Yes.
So it's negative 6 and a fourth. Is that right? Negative 6 and a fourth. Does that make sense? So I have negative 1.5 up here, right? For my x, because that's what 3 seconds is. And I have negative 6 and a fourth for my y. What am I going to do with this now?
Plot that.
I'm going to plot it. So here's negative 1.5, and then I'm going to go 1, 2, 3, 4, 5, 6 and a fourth. So something like that. That's my vertex, right?
Yes.
Okay. How do you plot? How do I plot other points? What do I need to do?
Pick.
You just pick numbers, right? Okay. If I were you, I would plot. I would do something like 0 maybe because that's easy, and I would do something like negative 3 because we want to pick one on each side. Or we don't even have to do that. We can just pick 0 and then reflect it. Remember?
Yes.
Okay. So let's plug in 0. So I have 0 squared plus 3 times 0 minus 4, which means I get negative 4. So 0, negative 4 is what I'm plotting. 0, negative 4. Okay, if this is my vertex, right,
Yes.
then I have to reflect it. It is 1.5 away, right?
Yes.
So 1/2 and then 1. So it's going to go right there. Now, is my parabola going to be dotted or solid? Because that's the next part. That's part of this, dashing it or making it solid.
Dash.
It would be dashed. So I'm going to dash this part of my graph. And remember that these are curved because it's a vertex or because it's a parabola. What makes a V?
Absolute value.
Absolute value. Okay. So now I have that. Now I need to test a point inside the parabola. Okay. If I were you, I would test the point. We can't test 0 because that's part of my parabola, so I would test negative 1, just because it's easy. Negative 1, 0. Okay? So we're going to test a point. So this was all step 1. Step 2 is test a point. We're going to pick negative 1, 0. So we're going to plug the negative 1 into the x. We're going to plug the 0 into the y. Is 0 greater than negative 1 squared plus 3 times negative 1 minus 4? So is 0 greater than 1 minus 3 minus 4? So negative 6, right?
Yes.
So yes, that's true. So if it's true, what am I doing now?
You're going to shade away from 0. I mean, away from.
Is that a true statement? 0 is greater than
Yes.
negative 6. So then that means that negative 1, 0 was on the inside. So am I shading the inside or the outside? No,
The inside.
the inside. If the statement is true, I shade inside.
Okay.
If the straight statement isn't true, I'm going to shade on the outside because I'm always going to pick point inside my graph. Okay? So I shade. Now I've graphed that. let's try graphing a set of equations, okay? Graph, we're gonna do y is less than or equal to x squared negative x squared plus 4, and we're going to do y is greater than x squared minus 2x minus 3. Okay, now we're going to graph 2 on 1, because sometimes we can do that, and that's okay. So we're going to graph 2 on 1. If you're graphing 2 on 1, I suggest you use 2 colors. Okay? Just so that you don't get confused and we can see stuff and what's going on. I'm going to go ahead and graph this first one in blue. Okay? Y is less than or equal to negative x squared plus 4. Okay, I need to graph this. What do I have to find out first?
You need to find the opposite of B.
Yep, over 2a. Is there a b?
Yes. Well, no.
No, so what is b?
1.
No.
0.
0. There's no b at 0. So 0 over anything is going to be 0. So my b equals 0. We got lucky on this one. Now, remember, I have to plug that into the equation to solve for y. So I'm going to say negative 0 squared plus 4, and that means y is, so my vertex is 0, 4. 0, 4. Nope, I lied. 0, 4. I can't think right now. There's my vertex. Beautiful. What do I do from there?
Pick a point.
And
Or a number.
yeah, pick another number, and then I graph the point off of that, right? So I'm going to go ahead and just pick 2. 2's easy, okay? So if I plug 2 into this equation, I have like this. What is 2 squared?
4.
And then 4 times negative is negative 4, and negative 4 plus 4 is
0.
So when I plug a 2 in, I get a 0 out. And I'm going to reflect that, right?
Yes.
Now, dotted or solid line?
Solid.
Solid, because it's less than or equal to. Should my graph be facing down?
Yes.
Yeah, because there's a negative in front of it, so that makes sense. Now, what's step 2 that I have to do?
Test the point inside.
Test a point inside. Okay, I'm going to test 0, 0 because it's inside. 0, 0 is easy. So I'm going to say 0 is less than or equal to negative 0 squared plus 4. Is 0 less than or equal to 4?
Yes.
Yes, so where do I shade? Inside. Okay, now we graphed all of that. Now we got to come over, and I'm going to make this one red. We're going to graph this one in red, okay? Step 1, what do I have to do? Opposite B over 2A. What is the opposite of B then?
2.
Okay, so I'm going to say opposite of B over 2A. So I have 2 over 2 times 1, which gives you 1. What do I do with that number?
Plug it back in.
And find the
Y.
vertex, the y, the y of the vertex. 1 squared is 1 minus 2 minus 3, which gives me what?
Negative 4.
-4. So my vertex is 1, -4. So I go to 1, I go to -4, 1, 2, 3, 4, and I plot that point. Now, what do I do from there?
I'll pick a point. You pick a number. Yeah, I'll pick a number.
Pick a number, plug it in. If I'm you, I'm picking probably 2 because it's next to 1. Or I'm picking 0. So which one do you want to pick?
2.
2. Okay, let's pick 2. So y is greater than 2 squared minus 2 times 2 minus 3. 2 squared is 4, negative 2 times 2 is negative 4 minus 3. What do you get?
-3.
Negative 3. So when you plug in a 2, you get a negative 3 out. 2, negative 3 goes right here. Now, what do I do with that point? I reflect it. Dotted our solid line now. Dotted. Good. Okay, now we pick a point on the inside again, and we plug it in, right? So I'm going to pick 0, 0 again. 0, 0 is easy. We want 0, 0 if possible, right? So I'm going to say 0 is greater than 0 squared minus 2 times 0 minus 3, yeah? Yeah. Is 0 greater than negative 3?
Yes.
So what am I doing?
Shading.
And look at where they overlap.
So in this lesson, we got to graph 2. They should overlap.
When you have to graph 2, they don't necessarily have to overlap. They can overlap. Okay. Well, if I'm graphing 2, you know, I could have one parabola that's here and one that's here, but it could be that they're shaded on the outside and those regions overlap. Does that make sense?
Yes.
So the parabolas might not always overlap each other. Okay. Let's see here. I think that's where I want to stop today. Tomorrow, Wednesday, we'll talk about using tables to graph. So basically tables is just you have to plug a bunch of numbers in. So it just takes a while. But you have to plug numbers in, plug numbers in, plug numbers in, and then you get your graph. Not hard, just takes a while. But graphing in general for this takes a while. So we'll do that Wednesday. Thursday we will look into 410. Okay? Thursday, Friday, and then the following week will probably be your test. Cool? Or it might be next week, because I think 410's not long, if I remember correctly.